questions has taken a long time. What we're going to do now, we're going to draw the graph. We're going to discuss symmetry, and we're going to figure out the center, major axis, and minor axis of this ellipse. What we're going to do now is we're going to zoom in to my graphing calculator. You will have noticed that I've already entered the equation. Once you enter the equation, you want to go to your window. And since you already know the extent of our graph, notice that our x's are between -5 and 5. And our y's are also between -5 and 5. I could have lowered them to be between -3 and 3. And now graph. This is what an ellipse looks like. Look very carefully at the graph. Notice y-intercepts 0, 3 and 0, -3. X-intercepts 5, 0 and 0, 5. So there's our graph. If you want your graph to be accurate, you can go second, table set. Notice that I set up my table to start at 0, and then I put the independent on auto. Now go to second and table, and the calculator did all the work for you. Plot those points, the points that you see there, and you'll get half of the graph of the ellipse. Please do notice what happens once we go past 5. The calculator gives us an error message. Good. Now that we know what the graph looks like, let's draw it. We're going to go on the board and draw the graph. Do notice that the important points are your x-intercepts and your y-intercepts. To the best of your ability, draw an ellipse. There it is. An ellipse is an oval. It looks like a football that's lying down on the graph. Okay. Let's talk about symmetry right now. This is the y-axis. What should you notice? Well, you should notice that the y-axis splits the graph into two halves that are mirror images of each other. Why is that important? Well, that is important because when you graph the ellipse, you only have to do half the work. In other words, if you know that this point, let's call it R, S, is on the graph, and you know that the graph is symmetric to the y-axis, the point -R, S is also on the graph. So look at that. If I just graph this half of the graph, I don't even have to do any work to get the other half. So this is y-axis symmetry. If the point RS is on the graph, then the point, the opposite of RS, also has to be on the graph. Let's write that down. So y-axis symmetry if the point RS is on the graph, then the point -RS is also on the graph. What else should I notice? Well, look at the x-axis. The x-axis itself splits the graph into two halves that are mirror images of each other. What does that mean? Well, for x-axis symmetry, if the point RS is on the graph, then the point R -S is also on the graph. Is this important? Of course it's important. Let's work for us. So if we know that a graph is symmetric with respect to the x-axis, we satisfy the following conditions. So x-axis, let's spell axis correctly, x-axis symmetry implies if the point RS is on the graph. So if RS is on the graph, then the point R negative S, or the opposite of S, is also on the graph. Okay. There is one more type of symmetry. It is known as origin symmetry. Now, for origin symmetry, what I would have to do is take this graph and turn it upside down. What would you notice? Well, what would you notice is the fact that the ellipse would look exactly the same. Now, I'm not strong enough to do that with our board, but I am strong enough to do that with our book. So now take a look at our book. We're going to take a look at the ellipse. We're going to take the book, rotate it 180 degrees. There it is upside down. What do you notice? The ellipse looks exactly the same. So now we're going to talk about origin symmetry. In origin symmetry, so this is origin symmetry. If the point RS is on the graph, then the point negative R, negative S is also on the graph. So let's write this down. Origin symmetry. If RS is on the graph, then the point, the opposite of R, the opposite of S is also on the graph. Again, we've spoken about this to see whether a graph has origin symmetry or not. Just take it, rotate it 180 degrees. If it looks the same, we've got origin symmetry. An ellipse has all four types of symmetry. When you graph an ellipse, it is enough to just graph 1/4, and then you know the other 3/4 of the graph as well. So, we're done talking about symmetry. Last few concepts that we're going to discuss, and then we're finally done with this example. We start with the idea of a center. So the first thing that we're going to do is figure out the center. This is the first focus. It has coordinates at -4, 0. This is the second focus. It has coordinates 4, 0. The red segment joins the two foci. The midpoint of the segment joining the foci is known as the center. So the center of an ellipse is the midpoint of the segment joining the two foci. Let's find the center in this case. So like I said, the center is the midpoint of the segment. So what we're finding is, we're finding the midpoint. So we're going to use the midpoint formula, -4 plus 4 divided by 2, and 0 plus 0 divided by 2. The center has coordinates 0, 0. So, center is the midpoint of the segment joining the two foci. Next, we're going to find the length of the major axis. The major axis, I'm going to use a different color marker. I'm going to use black. The major axis is the chord of the ellipse that passes through the foci. A chord is a segment whose endpoints are on the ellipse. So in black, what you see is the major axis. Major axis. Chord of the ellipse that passes through the foci. The foci have to be located on this chord. What is the length? Well, one x-intercept is negative 5, 0. The other x-intercept is 5, 0. And so the length of the major axis happens to be 10. So length of 10. Twice one of the x-intercepts. Okay? Finally, in red, I'm going to draw the minor axis. What is the minor axis? The minor axis is the chord that passes through the center and is perpendicular to the segment joining the foci. So the red segment here, the red segment that has one y-intercept as one of its endpoints and the other one as the other endpoint is the minor axis. What is the length of the minor axis? So minor axis has a length of 6. Length of 6. And is the minor axis related to anything? Yes, it is related to the number underneath the y. The square root of 9 is 3. Twice 3 is 6. What about the length of the major axis? Yes. In this case, it is related to the number underneath the x. The square root of 25 is 5. And I notice that the major axis has a length of 10. We also notice that the length of the major axis is the same as the sum of the focal radii. This example is final.